This video we're going to be covering iteration, what for loops and while loops are, how to write the equivalent of them in ARM assembly, and how we can apply them to solve problems. And this is going to be the final video in this whole Intro to ARM assembly series, so let's get right into it. By the way, all the old code from conditionals in the last video I saved into a function called game and put it in a file called game.s. So it's there in case we ever want to reuse it in the future. Alright, so for time purposes, I have actually written this code for the practice using the for loop ahead of time, and I'm just going to walk you guys through this. I know I normally try to write all the code on the spot so that I can concurrently show you guys how to fix mistakes while still showing you guys the concept, but this video was already very long, and I did write all the code on the spot for the while loop, which is later in this video, but for time purposes I'm just going to have to walk you guys through some code that I previously wrote. So yeah, let's get on with it. So, and besides, there were a lot of comments written for this file, so instead of writing them all on the spot, it'll be easier if they're already written and I can just use those comments to show you guys the logic behind this. So here we go. I named the function forTask because, well, we're practicing using a for loop. At the top, I have the stack commands. Again, please watch the stack video to understand that. And at the bottom, I have the closing stack commands. So it's everything in between that's the actual hardcore of the function. So the task was for loops, and this task involved user input. So the first thing I did was I prompted the user for input. So you can see here I created a label here called prompt, and if we go up here, the label prompt.ASCII, and it's enter a number and then \n for a new line. And it's basically, it's just asking the user to enter a number. Again, they can technically enter anything they wanted, but you know, for the code to work as intended, they would have to enter an integer. So once they do that, we load the address of their input. So you can see here for input we have this %d to indicate that it has to be a decimal or integer number. So we load that input. So again, like I said, should be an integer. And then in register 1, remember, when it comes to printf and scanf, or any function really, the first argument goes in register 0 and the second argument goes in register 1. So number here, you can see, was the input. It's like the integer framework for the user input, if that makes sense. Again, I made a video in the past for this series on printf and scanf, so you're welcome to check that out for more clarification. So number.word0.word again just means taking up 4 bytes, since integers take up 4 bytes of memory. And then, let's see. Then what I do is I save the user input into register 5. You can pick any register you wanted, as long as it's not clashing with registers 0 and 1, because we're using them. And then, yeah, so by convenience or convention, I've just always been picking register 5. And then what I do is, now comes the actual concept of the for loop. So you can see here I moved the value 1 into another register I picked, register 3, and this is basically the equivalent to int I equals 1 of a high-level language. Now, why do I need to do this? Well, notice here in line number 41, it says this is basically how you'd create a for loop in a high-level language here. So for int I equals 1, I is less than equal to number I plus. In assembly, you can't do that in one line because there is no such keyword as a for. Why I have this for? This is just the name of the label. I can call it anything I want, but for proper coding practices, it's good to call it for so that people know what it's doing. So in assembly, you have to first initialize the iterative variable or the loop variable. So that's why R3 is representing I in this case, and then I can actually write the word for here. Then the next part, you may notice that the next part of the loop is the condition, checking if I is less than or equal to number. So that's what I did here. I first did a comparison between I, which is register 3, and R5, which is the user input that we saved in line number 37. So we first compare to see if the limit is reached. BGT finalized, so I had to create a finalized label because if I is past the limit of number, if it's past the value of number, so if R3 is greater than R5, if it's equal to R5, it's fine, or the value in R5, it's fine. If it's less than R5's value, it's fine. But if it's greater than, then we've already finished everything we need to do. So we completed the iteration, so we go to this finalize label to exit the loop. And then, this is just, the goal of this task is to basically start at the number 1 and then print from 1 to 2 to 3 all the way up to the number that the user entered at the start of the execution of the program. So I apologize, I didn't clarify this, prior to walking you guys through the code, but, I'll make sure not to make that mistake again. So basically, we prompt the user for an input, and whatever number or integer the user enters, that number from 1 to numbers will be printed in order, in numerical order. That's the goal of this program. So for int I equals 1, I is less than or equal to number, I plus plus. First make sure that the condition for I is met. If not, that means we exit the loop, which would happen once we're done. And then, using the first argument of output and then the second argument of the respective number in that sequence, then we print that number. So that's what the BL printf is here. You may be wondering, why is there a push and a pop here? Well, because when I was writing this code, I realized that if I didn't have a push and a pop here, if I just had the printf after putting these arguments in, printf, because it's not our own function, we can't ensure that it won't erase some values, so we have to make use of the stack to make sure values aren't lost. So we have to push values registers 2 to 11 because, some of our values are in there, including the user input in register 5. And then we call printf, could have destroyed some values, doesn't matter because we just pop it back. And then we increment I, so this is the I++ part of the loop. So we just add 1 to register 3, and then put that as the new value in register 3. And then we branch back up to 4. So notice how when it comes to iteration, we first initialize the loop variable. Then we create the label name, then we check the condition. If the condition's good, we keep going, or else we exit. And then we just branch back up to 4. And what if the condition wasn't met? Well, if I is greater than the limit number, then it goes to finalize, which is underneath here. So it's not going to get to this line, in this line number 55, which is branch 4. It's not going to get there because it already went to finalize. So it's not going to keep iterating forever because it's never going to reach this branch to 4 line once the limit is reached. So in register 0, we load the address of a label called output, which you can see here is just our format string. If you guys know C, you'll know what that is. Then the \n for a new line, but this %d just means that it's the format string so that you can tell printf to that you're gonna get an integer, or that it's gonna get an integer. Same thing with this input here. Alright, and then we just move into register 1 because register 1 is where the second argument goes. The value in register 3, which is just the value of I, and I is always representing the respective number in the numeric sequence. Then we print, pop to preserve the values, increment I, and the loop goes on like that. And then finalize once it's done, and these are just our closing stack commands. Okay, so now let's run this. Let me just change the scene here. Okay, so make sure you save, and then, oh, another thing. In main.s, make sure you're calling the for task function. So let me change back real quick. So in main.s, make sure in between the stack commands you're calling the function for task. So bl for task. There are no arguments we have to put because we're just practicing calling functions. All the logic is in for task. So there we go. Now let me go back to the terminal. Okay. So yeah, okay. Oh, sorry, I forgot to change to my tutorial folder. Okay. Make sure it's saved. Now go to now compile gcc-d-o test main.s for task.s, and then run test. Enter a number. Let's go 5. 1, 2, 3, 4, 5. Make sure it's working. Let's pick another number. Let's go 18. Prints 18 values. You guys can't see the rest because stupid OBS is blocking it, but if I just put some new lines there, you should be able to see it. Alright, there we go. So that's the code, and that's how iteration, or specifically the for loop, works. So now it's time for the while loop. Okay, so now we're going to move on to the task that we need to complete for the while loop, or using the while loop, or the concept of it, because the while keyword doesn't exist in assembly, just like for. And I realized that I might have made the for task a bit too complicated for educational purposes, so it combined the use of a for loop / iteration in general with dealing with input and output, which can get really messy. So I'm going to make this task using the while loop a bit simpler. So what we're going to do is we're going to, again, very basic, I'm going to call the name of this task birthday celebration. Why? Because at the time I'm recording this, my birthday is in 2 days. So what we're going to do is in the last task, we asked the user for input, and from that input we got those loop variables, but instead we're just going to create a constant value for our loop variable I, so that, you know, we don't have to deal with all that messy stuff. So we're going to say while counter, which is our loop variable, while counter is greater than 0, print today is my birthday. And then obviously we need to create a label here. What is it? It's let's call it birthday. .ASCII z. We can just copy that. Okay. And then we decrement counter and stop when counter is 0. Okay, so this should be very simple. The first thing is we need to create a while label. Again, we can call this whatever we want, but for, you know, code purposes, it's a good naming convention to write while, since we're using the idea of a while loop. So high-level language equivalent, so while I is, or int I, is greater than 0. Then we want to, we need to first load into register 0 our birthday print statement, and then bl printf. So we're just gonna write a comment here. Once again, I made the mistake of coding before commenting. Print today is my birthday. Okay. And then we decrement I. So, oh, we didn't even initialize I. So let's use move R5, and let's create a constant value 5. So initialize I to 5. So in the for task, we created we asked the user for input, and then we used that to create a loop variable, or to get a certain value for a loop variable. But in this case, because we're taking out that part where we deal with user input, we're just going to have to create a constant value for the initialization of our loop variable I. So I'm just picking 5 randomly. Okay. And then the other thing I forgot to include first is we need to compare our value of i's before moving on with the rest of the while loop, because if it happens to be 0 or less, then the loop should stop, and therefore we just go to the end of the code, which is where we'll write a label here called finalize, just like we did for the for task. So we're going to compare the value in register 5 with 0. So compare I with 0. And if it's not greater than 0, less than or equal to, that's the same thing. Less than or equal to 0, to be a bit more clear. Then the loop ends. So BLE for branch less than equal to. Again, please watch the last video if you don't know what branching is. And then BLE finalize. So if it's not greater than 0, because this while loop only works as soon as, or while I is greater than 0. So if it's not greater than, that means it's less than or equal to. So then we go to finalize, which is just our finishing, our closing, our concluding stack commands. And then, so we print, and then we have to decrement I. So we just subtract value of our 5, which is, we initialize to be 5. And then, and that'll be our I, and then we branch to while, because it goes back up to the loop, then it compares and does the thing again. So since we initialized I to 5, if all goes well, this should print today is my birthday 5 times. And notice how this program is very robust, because we can initialize I to anything, and it'll print today is my birthday that many number of times, because that's how initialization works. And this while loop, like any good iterative loop should be, is dynamic to the value of I, and it has the proper condition and the checking of the condition. So let's test it. As usual, just make sure you have that compilation command. Cool. And now we just need to run test. Okay. And you can see it printed 5 times. That's because it's not exactly the prettiest output, because I forgot to add the \n. So let me just quickly do that. I'm using the window capture of OBS, so it's not showing for you guys, but I'd rather do this than record 2 scenes. So let's go ahead. I just fixed it. Let's do that again, compile, and then run. There we go. I added the \n, so it inserted a new line every time that we printed today is my birthday. So 1, 2, 3, 4, and 5. There we go. And what I'm also going to do is I'm just going to, for fun, just to show you how robust this program is, I'm going to change the initialization value of I to 6. And then we're going to compile again, and then it should print today's my birthday 6 times. 1, 2, 3, 4, 5, and 6. Beautiful. So this can apply for any value of I, and the program works just like that. First try. All right. Alright, guys, so as promised, I am going to give you guys some final noteworthy information to wrap up this Intro to Assembly series. So, the first thing, something that I've been using a lot in my code that I haven't exactly explained to you guys, it's .ASCII Z, the thing we put whenever we're creating a label, which is like a string of characters. Well, if you know what ASCII is, then ASCII is the set of characters that we can type into a computer, use with a computer, to say the least. But instead of ASCII ASCII, it's ASCII, and the Z is for zero terminated. The next thing that I need to mention is that a lot of the code I've been writing in this series is not always the most efficient approach to solving problems when you're writing assembler code. So usually, like, what I've been showing you is functions and subroutines. Subroutines is actually the generic term for functions. So there's actually two types of subroutines. There's functions and there's procedures. And basically functions are the ones with return values, and that's why it's easier to work with them. But the general term is subroutines. So in case there is no return value for some reason, that would be a procedure, not a function. So just in case, it's probably safer to say subroutine. And subroutines are not exactly the most efficient approach to every single, or it's not the most efficient approach to every single problem. So something that you could instead use is a macro. I did not cover macros in the series because this is an introductory series and macros are a little advanced. But the reason why they can be more efficient than functions/subroutines is because macros, they require less code, they take up less space when you're writing code, and they basically get copy-pasted in place. So it's like a subroutine where you're writing the name of the function, but it's a macro, and then you do all your necessary things there. But then it's more, or it's closer to high-level code, because when you want to use the macro, you just call the name of the macro, and then you just include the necessary parameters the way you would with a high-level language, just with slightly different syntax. So that's why I love macros so much, but they do take a lot of time to teach. Frankly, macros could be its own course, honestly. So let me know if you guys want to see videos on macros, because they are definitely pretty interesting. They make assembly efficient when assembly itself is not the most efficient language. So yeah. Alright, well, that's it. That's the whole Intro to Assembly series. I appreciate you guys so much for watching all 6 of these videos, if you have. Because assembly is a very tough thing to learn. Like, what I find tough is that people don't know how to set it up initially, and once you actually know where to go and what to do and what registers are and how the register mapping works, then assembly becomes very, very straightforward. So that's something that most people don't get. Like, most people don't get that initial setup and that initial understanding of how registers work and things like that. So that was my goal when I created this series. I wanted to bring clarity to that and then show you guys how easy assembly really can be. Of course, in modern practices, you're not going to use this type of language very often because there are more efficient languages. And throughout this channel, I am going to be posting a lot more programming tutorials and more things with more efficient aspects of computer science, like things like AI, machine learning. So I have a lot more interesting content coming up, so please stay tuned for that. So yeah, that's basically it, and I'll see you guys in the next video.